All right, we're going to go back to it. And we've got a talk that is a bit different from the rest of the agenda. This time it's about setting up eBPF using NICs. I don't think I've seen talks about NICs and eBPF before, so that sounds interesting. So that's Yifei presenting that for us. So yeah, go ahead.
Thank you. Hi everyone, my name is Yifei. I'm a PhD student at INRIA, and this talk will mostly be on the DevOps side. So if you're expecting very technical eBPF stuff, stay here after I finish the talk, please. Okay, so this is how this talk is meant to be like how I demonstrate how I use NICs to do eBPF related work, and the overall cycle is I use this specific laptop to do collaboration and dev cycles, and then use QEMU and VD switch to do virtualized networking between the virtual machines, and then you use a specific deployment tool that my supervisor wrote and to deploy into the HPC system at the cluster where I work at. And then I collect live metrics from the system as well. So I started a project for using developing a multicast caching system for a network file system over XDP. That project is running late. So why I'm presenting DevOps stuff right now. And a little background about NICs. NICs is a declarative package manager. It's also a functional programming language. And the concept of it is to take your source code and then call a built-in function derivation to transform your source code into closures. Closures are just packages built on your system and put into NIC store path. And NICOS is an operating system as closure. If you're interested in NICs and NICOS stuff, you can head to the dev room after this talk. So what is a testbed? Testbed is like a regular production system, but the code running on there are ephemeral, so it's short-lived. And for this specific testbed, it's called Grid 5000. It's a part of Slices FR, and it's a pretty big pan-European HPC project they're doing. Most of their stuff is open source. And the level of flow here, this graph I showed a little bit earlier, you can take this part and just swap this with there. So users SSH into over a access node, SSH jump host, and then you can interact with the backbone network and then the site-specific front end. So, for example, since I work out of Grenoble, I log into the front end and then go to the front end site for Grenoble. And if you want to submit a job, I used a tool called OAR sub. So OAR is a HPC job management system similar to Slurm, and you use kdeploy to deploy the actual initRD and kernel to the bare metal machines in the cluster. So the problems we're having is if you're doing a pretty big project and you need to synchronize the headers, the compiler versions, and sometimes LSPs won't even work with your editor. And if you have niche use case in some like guarded BPF helper functions like override return, you have to tweak the compilation flags and for it to be working properly. And since during the stage of development, most people use QEMU to do the local testing. But what if you have multiple machines involved, like 2 or 3, 4, and writing these commands can be pretty hard. You can do it though, and you want to set up. What if you want to set up networking between them? So better to use a wrapper tool for that. And what if you're doing booting inside a cluster and you want to collect a large amount of data and the automation scripts for those are non-trivial to write? And also, if you're doing academic work, you want the result to be reproducible. So the artifact evaluation, like evaluators can grab your stuff and then rerun. And so hopefully you get the SM batch artifact reproduced. So what worked for me is using a NixOS specific tool, but you can run this on a non-NixOS system with Nix installed. It's called NixOS VM Test. It's basically a wrapper around QEMU and generates scripts and to set up the virtual networking stuff and the starting script for QEMU VMs. So with this, you can have multiple machines running different kernels with networking between them. And you can also get the benefits for just using Nix, like, for example, binary cache and everything. So you only build one path exactly once and never again. And the deployment tool is called NixOS Compose. It's a multi-flavor deployment tool for ephemeral experiments, and it works with systemd unspawn, Docker, bare metal, and some other stuff I don't use. And you can substitute stuff with your own development tool. And to get user space tooling, so you can write your own package definition in here, and then inputs from will grab native build inputs, library stuff directly into your shell. So you don't need to worry about the versions and stuff. So that's really good. And then the compilers and the tools like LLVM strip will be included in there, like with this. And now if you want to use a weird kernel, let's say multi-kernel, and it's still in the mailing list, and the repo is public. So to do that, you can define a Nix file, and you specify the name, version, and what compiler toolchain you want to build it with, and the source. You can either use a local path or a file set, or just fetch from whatever Git forge you use. And then you can add your own kernel patches. Like it's a list of files or a list of patches can be fetched from where remote. And then the compilation flags. And then you invoke that with a boilerplate like this. You're done. You have the NixOS system with the specific kernel ready to go. And if you want to do testing on one machine, so you need to do boilerplate, like the invocation function, run NixOS test, and the name for that. And then the declarative NixOS closure, like with nodes.machine name, or can be whatever name you want. And then in here, it's just regular NixOS module, so you can write whatever you want. So here in this example, you're seeing SAX, the eBPF-based external scheduler. And with just this one line, you can have that in the machine. And down here is a block of imperative Python statements you can invoke. So this will be run in the non-interactive mode of the testing. And this can also be invoked manually in the interactive mode. And what if you want more machines? You just add a new block and then declare whatever you want. So this becomes really handy for me when I'm trying to deploy a benchmark with 15 machines, and just add 15 machines in here, or you can use a map function to wrap the config with shared machine, just different names, and then it will just be there. But what's inside the run NixOS test result? If you do a REPL, you can see that it's the config for the test itself, and driver interactive, the name, and nodes. Nodes in here contains the actual evaluated NixOS system call from the Nix package lib. And we've already talked about drivers. And the drivers will automatically include the scripts for starting QEMU VMs and VDE switch to set up a virtual networking between them. And I wrote a very simple BPF program to do StatX marking. So in here, I'm using the bad way of string comparison, and as the last talk specified, and then replacing the entirety of the statics call with a static 0, like almost every field is set to 0, and then you call on the override return function, which requires a special allow error injection flag, and BPF allow kprobe allow return or something, but you need 2 flags for it to work. And then in here, we also have a kReturn probe, so you can count how many times and get a histogram of the data we collected. So for user space programs, we're using Cloudflare's eBPF exporter. So it will load the object file for you, and then you have a shared YAML file where you define the BPF map. So it will read into the map, and your BPF program will write into the map and then export it through the Prometheus format. And then you can collect and plot the metrics with Grafana, and then the same thing will work locally and in a large-scale deployment. But in here, for simplicity, I'm only using a 2-node setup. So the program I just showed you guys will live in here, the source block of it, and then you give a name and a version to it, and then in the input and phases is where you declare the dependencies and compilers needed, and phases where how you invoke it and install it into your next store path. And then it calls a wrapper function packages stdenv.make derivation will call the built-in function derivation to build the package, and then derivation gets realized into a closure. And in this closure, you will see that if you have lib or bin or whatever, it can have dependencies, and this chain of dependencies forms a closure. And in my specific example, the object files are put into libexec directory under the store path. And then in this portion, you write NixOS modules to define your kernel packages. And in here, I'm overriding the standard kernel into a kernel with allow error injection flag enabled, and also configuring a systemd service to start the eBPF exporter to load the object files and export the metrics and HTTP reverse proxy so I can access it. And then down here, after the system configuration is evaluated, you can either use a local VM or physical machine to test it out. So for local testing, we've already talked about this. And if you compile it even once, and the future compilations will be pretty fast. And then you can push the cache to a remote server or have a CI system build it. So if other people want to do development as you want to do, they can just fetch the cache on the server, so their build will be fast as well. And if you're working at a very big company, your company might be interested in software bill of material, and Nix makes it pretty easy to track the dependencies. And this morning, at another dev room, the creator of systemd mentioned AF VSOC, and NixOS local test will use this to create a SSH backdoor and with one single line of code, so super easy. So now I will show you guys a demo for running 2 machines on a local machine. So here is the repository. This file is the BPF program I wrote. In the same directory, there's a YAML configuration for reading the map.
Could you increase the text size a little bit more?
Sorry, yeah. Is that better?
Yeah.
Okay. So that's the BPF program. That's the config. And then in the test is where I set up the module. So this is for local testing. For the local test, in the non-interactive mode, I want to check that on the export side, I have these flags enabled. And I need to wait for this to start. And then on the other node, I can cover the endpoint and see if everything works. And on the modified kernel machine, I will make sure that I can get zeros on the timestamps when the eBPF project, the object file is loaded, and then I'll disable the client program. So when I do the stat again, I can see the regular date again. Ooh. So this is the interactive test driver. As you can see, the systemd SSH proxy is enabled, and you can directly SSH onto the QEMU environment with vsock. Let's use start all to start two machines. So now the two machines are starting now. You can see the logs here. So after it's booted out, SSH onto the collector node, where it's not the collector, the collector node to get a port forwarding, so I can access the Grafana on my local machine. On the exporter node, if we create a file under TMP override, and then we stat it, you should see that everything is 0 because the object file is loaded. And if we disable the client side, unload the object file, you can see the data is back to normal. Let me restart it again. And then write a infinite loop. Do start. Let's head to the Prometheus side. Sorry, the Grafana side, and log in with default password. Admin. Skip this. Dashboard. Make a new dashboard. Visualization. Prometheus. Let's do a time series first to see the count. The metrics are prefixed with FSD, which means FOSDEM', and let's do the count. Run the query. You can see here is when we first put it up, you can see some going up, and then we stopped it, it's empty for a bit, and then we're running infinite loop. It's going at the linear size. If we go to histogram and change it to bucket, you can actually see the live data come in. So that's it for the local demo. Let me stop it real quick. Okay. And as you guys can see, it's really easy to start a 2-node setup. And even if you add more machines, it will just be a couple lines of code, and then that's it. And for production deployment, it's really nice that you can get bit-perfect reproducibility on some store paths. For example, the kernel and the object file. But for some programs compiled with OCaml or Haskell, you may not get bit-perfect reproducibility. And I think the maintainers are addressing this problem at the moment. So let's see what it goes. And since everything is in the closure, the entirety of the system, like the configs, the kernels, init, RD, everything, and it would be very easy to write a deployment harness. And now let's do a production deployment demo. So in here, I've SSH'd onto the Grenoble node of Grid 5000, and right before starting this talk, I deployed the exact same environment to a two-node setup, and you can see Dahoo 19 and Dahoo 21. Let's make the text bigger. And if I start a new tab and do K-console. K-console is a way to see what's going on the machine. Let's copy 19 here. So this is the collector node. That's the export node. And if we check the kernel config, error injections is indeed enabled. If you go back to the regular node, and a collector, exporter, have function is enabled, but the function error injection is indeed disabled, so it's not touched. And on the exporter node, on the collector node, let me get the IP address of that. And in here, we should be able to log into Grafana as well and see the live metrics coming from the exporter node. Skip this. Prometheus. And yeah, we do indeed see data here. And that's the end for the production demo. And in conclusion, what you guys just see is made with less than 250 lines of Nix code, so it's very easy to implement, to do. And you also get portability with it. So all the codes you saw can be ran on your machine if you tweak a little stuff to fit your program. And adding another another eBPF program to the deployment will be as easy as adding the name for the object file. That's it. And now I'll take questions.
Thank you.
Google Chrome is not happy because it's cropping something here.
Sorry, I'm curious too, because the things that you show here, it's against kernels that have been either packaged in NixOS or in GitHub that you can compile. Have you tried, I don't even know if it's possible, but like kernels that, for example, Ubuntu or Fedora uses, so you can actually test against things running for those?
You can, yeah. So you can grab whatever source you want. So for example, in this page here.
Yeah.
So if you change the owner repository or whatever source you want, if you tweak the configs a little bit, you can get it compiling and then it should work.
Okay. A follow-up question. Do you know if there is people building packages for NixOS, but kernels running for other OSs?
Ooh. I'm not aware, but if you search for a project called System Manager or something, it allows you to manage configs and everything in other operating systems. And also there is another project I forgot the name of, and it allows you to run NixOS tests in not only NixOS VMs, but in Debian VMs, Arch Linux VMs, whatever VMs you want. So I think.
Okay, awesome.
Yeah.
Okay, thank you.
No more questions?
So I had a question. You mentioned earlier that some package repositories might be like completely reproducible, like byte perfect.
Yeah.
Do you know what the differences are between those that for which that works and those that for which it doesn't work? How would BPF be affected by that, possibly?
So for non-bit perfect store paths, for example, I believe OCaml programs are not bit perfect reproduced because in somewhere during the compilation stage, the types, the tags for the types you're going to strip in the library file, header files will change because that part is non-deterministic in the OCaml compiler side. So that's a portion of why it's not 100% reproducible. But if that one gets addressed upstream, it should be.
All right. Thank you. And another question. You mentioned that one of the motivations for working with Nix, for example, was to help with sharing your environment with some other people, like for getting reproducible, struggle with that word, builds or results. Have you shared your environment with colleagues for working with eBPF before, and how did that go?
So I've shared it with my supervisor. I'm not sure if he's actually running my code, but he's happy with it. And I have multiple machines. I have this laptop and another laptop running in the lab, and a couple more pretty powerful machines in the cluster. And I just only need to clone the repository and run dir and allow so that all my development environment gets on the same machine exactly how I want, including the LSPs and everything. So it's pretty good.
Excellent. Is he going to watch your talk? Your supervisor, is he going to watch your talk?
I think so.
So he should definitely, on behalf of the eBPF organizing team, he should definitely try it so that we can know.
Yeah, and I can show you guys one more thing. In this repository, the reason why this file does not have diagnostic is because I didn't run with Bear. So if I clean the build repository and then do a Bear with it, and then it generates the compile command, and then I go back in again, now everything's good. Client is running. Easy as that.
Right. And concretely, if I wanted to try your environment, I just need to install Nix on my machine, and then I can
clone the repository, and then run Nix develop with your preferred shell, ZSH, whatever you want, and then you should get the same environment. Yeah.
All right. Thank you. The Nix store as well. Yeah. Coming when you install Nix, or is that some additional stuff?
Installers you can use. So it's going to set it up if you use the installer.
So if I use the installer, it sets it up automatically. Okay.
Yeah.
Thank you. Any other questions? Going once, going twice. All right. Thank you.
Thank you.